Hi, my name is Dan Lewis. I'm a materials science and engineering professor at Rensselaer Polytechnic Institute, and today I'm going to talk to you a little bit about what is materials science and engineering and what materials engineers do. Materials engineering folds together different disciplines like chemistry, physics, and engineering, and we're concerned with things at length scales that are like micrometer length scales. That's a millionth of a meter. So it's bigger than the distance between two atoms, but smaller than something you could hold in your hand easily. Materials engineers worry about the structure, processing, and properties of materials and how those properties could be engineered so that you could make things lighter, stronger, or more functional than currently available materials. So in order to demonstrate the relationship between properties and processing of a material, I've set up a small experiment using a polymer spoon, so a polystyrene spoon, a mug that we're going to fill with hot water, and I'm going to demonstrate how the chains in this polystyrene spoon can move past one another as the temperature goes up. And so I've got a simple model here of a polymer. And so polymers are glassy materials, and their molecular structure is sort of all messy and confused like this string. It's not exactly how it works, but this is a pretty decent model. And at low temperatures, all the molecules tend to move together, and it makes the material very stiff like this spoon. So even if I try and bend this spoon, it springs right back. Now at higher temperatures, what's going to happen is these chains are going to start to move past one another at very local levels, like individual monomer units can slide past one another. And what that's going to do is it's going to allow this spoon to deform at slightly higher temperatures and retain its shape once it cools down. So we're going to go ahead and do that demonstration. I have a helper here that's going to work with me, and we'll be right back. All right, so what we have here is we have some water that's boiling in the kettle, and you can hear that. It's just starting to whistle. So what we're going to do is turn this off, okay, and then we're going to carry this kettle of water over here, and my helper is going to get in place. And you're going to grab that plastic spoon. You got it?
Yep.
All right, here we go. I'm going to put that water in, and what I want you to do is I'm going to put this back over here, and what I want you to do is put that spoon in there and push it down to the bottom just a little bit. You have to push a little bit harder. A little bit harder. Hold it there. Is it bending?
Yep.
All right, let's go ahead and pull that out. See what it looks like. Whoa, check that out. Check that out. Hold it sideways so we can see. Look at that. Look at that. Now try and bend that spoon now that it's out of the water. Is it too hot to touch? Is it bending?
No.
It's snapping back to where it was, right?
Yeah.
Maybe just tap it on the table. Let's hear it. All right, and so there you go. That's a pretty simple demonstration of how when you take this polymer up to slightly higher temperature, the molecules can slide past one another and that material can deform. So now this property processing relationship in polymers, we can demonstrate like this, but materials engineers are interested in that for all materials: metals, ceramics, polymers, foams, composite materials, glasses, all those things. So if you have any questions about materials engineering, whether or not you think you'd like it, get in contact with me. My details will be at the end of the video. And thanks to our helper. Thank you, buddy. All right. Catch you guys later.